Photography and AI are all the rage, but we're going to talk to a true pioneer of the field, mixing nature with AI. Stay tuned for this next episode of the Cozy AI Kitchen. So Sora just came out and I rendered a video of a Sumatran rhino walking through the jungles of Indonesia, but I know nothing about rhinos or the jungles of Indonesia. Luckily, we have a special guest. Welcome, Corey.
Hello.
This is Corey Jaskoski. He is a Rolex National Geographic 2020 award winner. Welcome, Corey, to the Cozy AI Kitchen.
Thanks. I'm happy to be here on your refrigerator.
So you've been doing machine learning for quite a while, and photography and exploring.
I sure have. Yeah, I started out in my career in course 6 at MIT, which is electrical engineering and computer science, but was also in love with photography and imaging. So found a way to blend those together and have made a career of that.
And I understand you have some of that exploration materials you want to share in the Cozy AI Kitchen.
We do, yeah. One of the things we want to really show is how AI these days and modern embeddings can be used to find things in imagery. You know, at my heart, I'm an explorer. I've explored every continent in the world and many countries for conservation and cultural heritage site preservation. And I've always thought that AI should allow a person to effectively explore data sets in that same way. And I'm going to show a little bit about what we built to allow us to do that.
And I noticed you knew something was wrong with my rhino.
I did, yeah. So although the video is amazing and the jungles of Indonesia that you've rendered, they're actually look an awful lot like they look to me in my memory. However, the rhino has a few non-Sumatran rhino issues going on. So first of all, in Sumatran rhinos, of which there's only about 80 left in the world, the horn on the front of the rhino is actually much smaller, usually about this big or so. And the ears are more rounded versus the triangular. This, looks to be some sort of maybe African rhino. Maybe Sora made some adaptations to make it a little bit more towards the Sumatran rhino. But the reason I know a little bit about Sumatran rhinos is actually this is how the inspiration for my company started. I was working with National Geographic and doing 3D scanning with cameras. So we were doing a lot of cultural heritage sites where we use laser scanners and cameras to actually capture, say, the whole of Chichen Itza or Petra or different churches and cultural sites. And one day I got asked if I could 3D scan a living Sumatran rhino. And the challenge, of course, is Sumatran rhinos move, whereas archaeology does not. So we built this giant camera array of synchronized cameras that were all synchronized to a fraction of a millisecond. And the idea was when the Sumatran rhino would walk out in front of them, all these cameras would fire and it would build a 3D scan of the rhino. And so we pulled this off and we got this beautiful 3D scan of the rhino. And what it got me thinking about is how we can think about the way that we train AI differently. So right now, when you train AI with imagery, traditionally you go through and label gobs and gobs of data. It's this really repetitive, error-prone human task that you need to do, this labeling in order to build models. And we started out with the idea, well, hey, could we generate this synthetic data from these 3D scans and build models that would then train AI? And then, after working on that for a while, what we really realized was that the real ticket is embedding spaces, just like ChatGPT and the like use embedding spaces in the large language models. We found a way to do that in imagery that allows you to build AI models without all the pain of labeling and explore data.
So you're an expert on rhino embeddings and more. So you have a demo to show us.
I do, yeah. Let's switch over to the demo here. How we can use imagery and embeddings to actually do large-scale search across data. So what I'm going to show you here is, this is Milwaukee. So this is millions and millions of tiles of map imagery. And if we zoom in here on some of this imagery, you can see this is really high-resolution imagery. And traditionally, if we wanted to find things in this data, whether it was Sumatran rhinos, of which there are none in Milwaukee, I can be certain of, or if we wanted to find rooftop air conditioners or swimming pools or whatever we wanted to find, normally we'd label this. We'd crawl across this whole data set. We'd label imagery. We'd build an AI model. Maybe we wouldn't have all the labels we need. We'd have to start that over. And that's the reason that it often takes months to build an image-based AI model, even though there's great no-code tools to do the actual AI training. like the like Azure Custom Vision, for example. But you still need that data to run a training. So let's take something like this boat here, and I'm just going to draw a box around this boat,
This is
and
very
I'm going to go
cool.
ahead and hit search. And what's happening while this is cooking in the cozy kitchen oven, I'll explain to you a little bit about what's going on in the background. What's actually happening is, just like with ChatGPT, there's a tokenizer that takes all of the words and sentences and paragraphs, and then an embedder that takes all of that information and embeds it into a mathematical space. Then when you search ChatGPT and you ask it a question, it can actually go and map your question, tokenize your question, map it into that mathematical space. Now we've got your question and all of its corpus of information in the same mathematical space. And with the power of transformers and the amazing work that the OpenAI team's done on ChatGPT, they can actually come back with an answer that's usually really amazing and really accurate for what you're looking for. Well, we're doing something similar to that, but in the image space. So in the image space, we don't have the advantage of having sentences and words that are, that have white space between them, so you know which is a word. We have to look at the world as, what are all the objects in the world? So what we're doing is, we've actually built a tool that can look across broad scale imagery, so millions and trillions of pixels, and can break it up into basically these embeddings. And then we can search across those embeddings just like ChatGPT does. But since it's in the image space, unlike with a large language model, where a large language model can give you a couple of replies, it can't give you thousands of replies for you to look through, because that would be tedious. But in the image space, we can. So we took this one image that got mapped into our Rake embedding space, and Rake is showing us the things that it thinks are similar. And if we zoom in, sure enough, Rake is in fact finding, that was a boat with a blue cover on it, finding those. It's finding lots of those, in fact. And over here, it's finding other boats. If we look around enough, we'll start to see, here's boats with white covers on it. Rake takes that image, maps it into its embedding space, and returns things that it thinks are similar to that. And now all we need to do, if we were looking for boats across Milwaukee, is we go ahead and we interact in this mathematical space by drawing a polygon around the sorts of things we're looking for. And after we do that, there we go. And we've already, we got lots of boats here. We'll stop drawing polygons here, but lots of boats. And here we go. Here's boats it's finding all over the area in Milwaukee. And if we zoom in and look at some of these, sure enough, that's actually the boat we searched from, I think. But let's look around and see what else it's finding. Yep, it's finding boats all over the world. All over. Yeah,
Corey?
You bet.
First off, you're doing Rhino embedding space, and this is exciting. One question that came to mind that comes into the Cozy AI kitchen a lot is that when different younger people see people like yourself who are crossing AI with nature, becoming a bona fide National Geographic award-winning explorer, and you got the MIT math, you've got the explorer energy, you're a photographer, artist. How did you start doing this? This is not normal. Can you help the viewers understand, how did you get to do this from MIT?
You bet. That's a great question. So when I was in grad school, I was taking a pure engineering focus, and photography and videography were just a hobby of mine. And I honestly never thought I'd be able to blend those together. I thought I'd end up in a traditional computer science, electrical engineering role, and just always have a hobby of photography and videography. But I was really fortunate. While I was in grad school, I was actually working at a robotics company and building power systems that could power underwater robotics. And one day, James Cameron's team, who did Titanic and Avatar and all those movies, actually called our small company up looking for these batteries to be used inside robots to film the inside of Titanic for the first time ever. And I ended up actually getting to go on the expedition, and ended up 12,500 feet deep in a 3-person submarine on the deck of Titanic, helping to run these robots around inside Titanic. And really, it was that minute, it was sort of the epiphany for me, wait a minute, I can actually combine photography, exploration, and hardcore engineering into a career.
Well, sorry to interrupt your demo, but keep on going. And I think that journey to you seems very natural and normal. But I think to everyone out there listening, you can do AI, you can do nature. There's so many people you can become. Definitely, Corey is a great role model for you out there.
Thanks. And yeah, the and what our tool really lets you do too is effectively that sort of exploration. Whether you're looking for Sumatran rhinos or whether you're looking for boats, parked in driveways, whatever you're looking for, even at global scale. I've always wished that AI, vision-based AI, was that sort of exploration feel. And really, vision-based AI is months of training models and labeling data. So what we've tried to get is a tool that sort of bypasses a lot of that and gives you an ability to really explore data sets. And it's been used for some pretty cool things. So one thing that we've used this for is we actually we found the Chinese balloon right after it got shot down over the United States. We found it in satellite data, but not only that, we traced it back all the way to its launch site. So we processed 18 trillion pixels of data in just a couple of days. We found the balloon 12 times and traced its entire flight path all the way back to where it came from. But back onto the nature side of things, some of our partners that have used Rake to have the effect of what they're looking for is the Nature Conservancy actually used our tool to look over data that they took from drones over the Palmyra Islands in the Pacific. Wow. And their goal was to count the known birds. They knew which bird species were there. They wanted to count the number of each of them, and they wanted to use Rake to do that. But what surprised them and surprised us is when they went over the data, they started seeing some anomalies in Rake, just like with this little boat demo where you can actually see this cluster of boats. You can actually see things that are clustered differently as well. Like, I don't know what these are, but Rake is like, hey, do you want to pay attention to these too? Well, when they did that for the birds, what they actually found is two birds that they thought were locally extinct on the island since World War II, the blue noddy and the wedge-tailed shearwater. They didn't think they lived on these islands anymore. And, according to them, without Rake, they never would have been able to find those birds by looking at the images manually. So really cool use case where, the Nature Conservancy probably couldn't have, had enough data or enough funding to build a large scale model for these bird species they thought probably didn't exist on this island. But using a tool like Rake that brings the power of image-based embeddings right at the user's fingertips was a great way to actually make a new scientific discovery.
So Corey, first off, make sure you check out Corey's work on the web. It is expansive and it keeps on growing. And maybe Corey, if you could close off this kitchen visit with really advice for the young Coreys out there to do what you're doing today.
Well, that's great. Yeah, my advice for the younger generation out there that wants to blend any sort of technology, AI, engineering, and answering important questions in conservation, cultural heritage, site preservation that I've had a lot of my career at National Geographic is really this. It's to take chances. When you are in school, you're generally going down a path where you're thinking about your future career and how much money you can make. But the thing you can't forget is that your future career is really most of the rest of your life. You have to follow your passion. You have to do the things that really get you excited to wake up in the morning, and don't ever lose that focus. And you can do pretty much anything you want in the world.
And if you take that advice, you might become a Rolex National Geographic Explorer one day. Thank you so much, Corey, for coming to the kitchen.
Thanks for having me. I appreciate it.
It is possible to be a Corey. Be Corey. See you next time.
See you next time.